This video is about geometric series. We've done arithmetic series, now we're doing geometric. Okay, so there's two kinds of geometric series. There's a finite series and there's an infinite. Finite means it has an ending, so that there's a value on top of sigma other than infinity, okay? Finite geometric series means you're going to use this equation right here, and it is on your formula card. You do not have to memorize it, but you do have to know how to use it well with those calculators, all right? So notice in the formula you've got to know what a sub 1 is. Well, you know from the equations that we always did a sub 1 times r to the n minus 1 power, right? So when you look at an equation in sigma form, you know that a sub 1 is the number outside the parentheses, r is the number inside the parentheses. So you just translate that to the new equation. All right, so in this case, a sub 1 is 4. R in this example is 0.3. So when I put my values in, I'm going to have 4 times 1 minus 0.3 over 1 minus 0.3. Okay, that 0.3 is to the nth power. What is n? N is up here. It's 12 in this problem. Okay? So what you want to make sure you do in your calculators is that you enter it just like this. 1 minus 0.3 to the 12th power. Hit enter and then divide it by this difference. So hopefully you could do that difference. 0.7 is the difference on the bottom. Okay, you could get there. And that will give you, let's see, what does it give us? Four times all that. When I put that in the calculator, I get 5.71. All right? Now, let's pretend just for a moment that the equation was this. Okay? Notice the r is a negative value. So let me just give you a warning. When you're putting this in the calculator, make sure you do not change the sign right here. I'll show you what I mean. Right here, you might be tempted to think, oh, minus times minus makes a plus. Well, don't do that because it's negative 0.3 to the 12th power. 1 minus all of that mess. So let the calculator figure out this value and then subtract it from 1, then divide by 0.7, then multiply by 4. Okay, so just be real careful. So just be real careful with the double negative possibility there. Okay? Now, all right, so infinite geometric series is when the infinity is on top of the sigma. Okay? That means it's infinite, right? So you might be like, how do you find the sum if it goes on forever and ever? That's a great question. Infinite series can either do what we call converge or diverge. Converge means that it does approach a unique number, that you can't actually get a sum, or it diverges, which means it doesn't actually approach a number and you can't get a sum. Okay? And how do you know? Well, you look at the value of r in the equation. If that r value, if you take the absolute value of it, is less than 1, then it's going to converge to an actual number. If that absolute value of r is greater than 1, then it's going to diverge, and it doesn't really make a sum. So we say it does not exist, or we say it's undefined. Either way is fine. Okay? And then this is the equation you're going to use for infinite series, so make sure you're using the correct one. Notice you have to use a sub 1, and you got to know what r is. So look at example 2. We know it's infinite because of the infinity sign. We look at r. Remember, a sub 1's on the outside here. That's an unwritten 1, but a sub 1 is 1. R is a positive 1/2. Okay, so if I take the absolute value of r, I get 1/2. It is less than 1, which means it will converge, and I can use the formula. All right, so let's just do this. So the sum would be a sub 1 is 1 over 1 minus 1/2. Well, hopefully you know that 1 minus 1/2 is still 1/2. And before you jump into a calculator, think about this. You're dividing 1, keep it, change it, flip it, right? Because a fraction, change it to multiplication, flip this over, and it becomes 2. So this one actually converges to a sum of just 2. All right, they can become that simple. Let's try another infinite series. Okay, here's the formula if I can use it. First, let's look and see, does it diverge or converge? Well, here's a sub 1, and here's r. R is 1/4, absolute value, that is 1/4, and it is not less than 0. It's less than 1, so it will converge. So I'm going to use my formula. So I have 4 over 1 minus 1/4. All right, again, let's think about this. 1 written as a fraction could be written as 4 over 4, right? If I simplify that, I have 4 over 3/4. Keep it, change it, flip it. I get 16/3. Okay? And that would be the number that it converges to, 16/3. No calculator needed, no big deal there. All right? Now look at example 4. It's not as obvious. It's not written with the formula. So first of all, I have to find r. Remember r, you have to do the second term divided by the first term. Okay? So 6 divided by 8. Okay, let's reduce this, obviously, by 2. So I'm going to get 3 over 4. So r is 3/4. R is absolute value of that. It is less than 1, so it's going to converge. Now I can use my formula. A sub 1 is 8 over 1 minus 3/4. Okay, 1 with a written as a fraction would be 4/4, right? Minus 3/4 is 1/4. So what I really have is 8 divided by 1/4. If I keep it, change it, flip it, it would converge to 32. Isn't that fancy? Okay. All right, let's look at this one. Another infinite. Let's just see where this goes. All right. Again, you've got to find r. So it's a sub 2 divided by a sub 1. A sub 2 is negative 1/3 divided by 1/9. Okay. Keep it, change it, flip it. Okay. Multiply straight across, remember? So I'll have negative 9 over 3, which is negative 3. Well, this is r, right? Absolute value of r. Is it less than 1? Okay. Absolute value of negative 3 is 3. Is that less than 1? No. So this one would diverge. So I would say it does not exist. Okay. But I have to find out what r is first before I can make that conclusion. All right. That's all you have to do for infinite geometric series. It's all about formulas, knowing about convergence and divergence. All right. Good luck, and we'll see you in class.